Good morning, dear students. How are you all? So, dear student, the second video of class 10 for the week, and in this video, we will talk about the chemical properties of metals. As we know that the very first properties you can see that metals are electropositive elements. What does it mean? We will talk in detail. You can see here metals are electropositive. What does it mean? If suppose M is one of the metal, this M is having 1 comma 2 comma 3 electron every time would be present in their electronic configuration in their valence cell. So this one can this metal can lose 2, it can lose 3, it can lose, and then it will form M minus 1 electron. What it will form? M positive, M minus 2 electron. What it can form? M 2 positive, M minus 3 electron. What it can form? M3 positive. So you are seeing this one, that metals every time forms some charges, positive. After losing that one, it is forming some of the charges. Due to the lose of electron, it is forming positive charge. So that's why its name is electropositive. If you will break that electropositive, the word electro plus positive. Electro means electron, positive means positive would be there, charges would be there. So that's why after losing the electron, it is forming some charges, and that one is positive charges. Okay, so that's why the metals are called as electropositive. I hope you have understood. I am giving you some example that will clear your concept. Here you can see Na. What is the electronic configuration of Na? 2 8 1. Okay, now this one is extra, which actually prevents this sodium metal from the stability, from completing its octet. So why it is not uh, why it will not lose by this sodium metal? It will lose by this sodium metal, and it will lose one electron, and what it form? Na positive. Okay, you can see Na positive. So one electron has been lost. Now some non-metal will definitely gain this one, and I am giving you that example. Cl 287. Here you can see this 7 is not octet, so it will gain this one electron which has been lost by sodium, and this will form Cl negative. So chlorine is electronegative, but sodium is electropositive, and you have to understand this thing. Okay, so metals are having the losing capacity. Losing capacity means they every time want to lose their electron. Okay, now if one person who has extra money, who have extra money, what they will do? They will donate. Okay, now they'll donate, they will serve to the poor people. So this Na is a rich one, and it is losing its electron. It is losing its electron, and it is forming electropositive. But Cl require something. Okay, now according to this one is a poor one. Okay, now so that absorb, that will gain one electron. Now you will ask me a question, sir, 7 electron it cannot lose. It cannot lose. Or if 7 electron will lose by this chlorine, what will you write? Cl7 negative, no problem. If you will write anything, but who will gain this one? Who will gain this one? This one that need lots of energy, and that is not enough for any of the element that they will gain 7 electrons at a time. Okay, now so that's why it is the thing you have to understand. Now you can see the next thing I am going to talk about, and here you can see sodium and potassium are electropositive elements. We have discussed metals are good reducing agent. Why metals are good reducing agent? Because you can see I am showing you this one. Metals are good reducing agent. Why? If I am writing Na, in the electron dot structure, one electron will be there. You know, no? What is the electronic configuration? 2 at 1. So 1 I have written in the dot form, and if Cl 7 would be there, this electron can come here. This electron can come here. So this one is easily losing its electron. This one is easily losing its electron. Okay, na? And if someone is losing easily its electron, then they are act as a reducing agent, and reducing agent just opposite to oxidation. Means if one is reducing agent, that means it should be oxidation. So you know this concept now. Okay, so now first of all we will talk about the reaction of with oxygen, and here I am showing you some of the reaction that there you have seen. Metal plus oxygen, metal oxide would be there. So I am showing you Na plus O2, Ca plus O2, Mg plus O2. What it will form? It will form Na2O, CaO and MgO. What is essential in this one? In this, it is essential that you don't need to write incorrect compound, because you know Na, what is the Na charges, or what is the charge on the sodium? 1 positive. Okay, na? And what is the charge on the oxygen? 2 negative. So 1 here, it should be multiplied with 2. So that's why 2 I have taken. Why I have not taken with Ca? Why I have not written Ca2? Because you know calcium has 2 positive and oxygen has 2 negative. So I have not taken Ca2 positive and O2. I have not taken Ca2 because it is already balanced one. Same case is with the magnesium. Okay, na? It has 2 positive charges and oxygen 2 negative. So plus 2 and minus 2, the resultant would be 0, and hence we can say that is true, that MgO, CaO, but Na2O we have to write. Okay, now the next thing, here we have discussed about this one. Now we will talk about the characteristic of metal oxide, and you can see characteristic of solubility in water. First of all, metals oxide are usually insoluble in water. Metal oxide, all the metal oxide are insoluble in water, but here the exception is given. Na2O plus H2O, and that when the sodium oxide, when dissolved in water, it form sodium hydroxide. So we can say this one is we have to understand that sodium, potassium, calcium, when it will form its oxide, sodium oxide, potassium oxide, calcium oxide, they can easily soluble, they will easily show solubility in water. What is the meaning of basic and amphoteric nature? You know, basic means, if I am talking about Na2O, what is this one? Na2O is basic. You know, plus if I will take HCl, okay, na, this one is acid. So what it will form? Basic plus acid, salt plus water, 2 NaCl plus H2. You can form salt plus H2. Let's see. What is the meaning of amphoteric? What is the meaning of amphoteric? Amphoteric is a property of some of the oxides that they can react with both acids and base. Have you seen this one? I am giving you one of the example. ZNO plus HCl. This ZNO is metal oxide. As you know, this one is basic plus acid. What it will form? ZnCl2 plus H2. Okay, now one more example I am giving. This ZNO can react with NaOH also. Okay, now this ZNO have reacted already with HCl, and this one will react with the NaOH also. So you should know that sodium zincate will be formation. We have discussed now. So amphoteric means what? Some of the substances which can react with acid as well as base. One more example is ZNO. Note down, ZNO is amphoteric, showing the amphoteric nature, and one more compound is there, that one is Al2O3. Al2O3 can also react with HCl, can also react with NaOH. Okay, dear students, so I hope you have understood this thing. Now we'll discuss for the reaction of metals with water. Metals actually react with water to form metal hydroxide. if I will take K plus H2, what it will form? Metal hydroxide KOH plus H2 gas. This in the practical you have also done that one. Okay na? And here you can see with the steam, if H2O is there, metal, this potassium is very reactive. With cold water it can also react to form KOH plus H2. But if some less reactive elements are there, then with the steam it will not form hydroxide, it will form metal oxide. Okay na dear student, metal oxide and hydrogen gas, but it should be less reactive. Why I will take the more reactive? Because more reactive is, if it is reacting with cold water, then why I have to invest so much money to form steam? Okay na? So less reactive will react with the steam. Okay, thank you all of you, take care of yourself.